Fusion Mobile, quality e-learning experience on the go.
Hello and welcome to our class today. For our topic today, we'll be talking of coordinate geometry. The first thing we'll be considering are rectangular axis of a Cartesian coordinate. Rectangular axis of a Cartesian coordinate, and how do we obtain this rectangular axis of a Cartesian coordinate? First of all, we feed a line, a vertical line, and then a horizontal line. Okay, and these lines, we've always come across them whenever we want to plot our graphs. Okay, and this we call the y-axis, and this is the one we call the y-axis for negative values, x-axis, and then this is the x-axis for negative value, y for negative values. Okay, and just like we have here, we have 2 points. We have two straight lines drawn perpendicular to each other, and they intersect at a point here we call O, which is the origin. Okay, and so you see we have this vertical and we have the horizontal line. Okay, just like I have denoted, we have y, and then we have the origin and y. Okay, the y and the origin and y makes up the horizontal line, the vertical line rather. Okay, all right, and so for x2, this is the line made up of x, the origin, and negative x. All right, and so we call this the x-axis, as we've always mentioned in a graph, and then we call this our y-axis. All right, and as depicted here, you see that there is negative y, there is positive x, negative x, and positive x, and we've always used this to denote positive values whenever we want to draw a graph, but we'll be considering it from a different perspective this time around. All right, and so the distance of a point from the y-axis is called the x-coordinate. The distance of a point from the y-axis is called the x-coordinate. So distance of the point of the form this. Okay, distance of the point this is called the x-coordinates. We call this the x-coordinates, or you can call it the abscissa. All right, and then the distance of a point from the x-axis is called the y-coordinate. Okay, the distance from the point of the x-axis is called the y-coordinate. All right, and so this is the one we call the y-coordinate. Or you can call it the ordinate. Okay, and so we have that if they two meet at the point P of x and y, okay, then we shall say that the point P is located on the plane xy. All right, as you can see, where there are equal distances, not equal, or there is a distance between the coordinates, and then the line of the abscissa and the line of the ordinate meet together to form the point P. All right, okay, so this line are formed by using the two distances. P is formed by using the two distances. All right, I hope you understand that. Equation of the lines equation of the axis, x and y are given as x equal to 0 and y equal to 0 2. Okay, but if actually we take another illustration where we have the lines given as follows with values, okay, well, we'll have this, and this time around we have values fixed to the coordinates and the ordinates and the abscissa. Okay, suppose that we have a line parallel to y to be equal to 2. Suppose we have a line parallel to y to be equal to 2 to be at x, where we'll have 2, and I mean here is 1, and then 0, and then 3. Alright, and then here is minus 1, minus 2, and then minus 3, and then here is 1, 2, and 3, and 4. Alright, so at this point we have minus 1, minus 2, minus 3, and so on. And so I'm supposed to have a line parallel to the y-axis. Okay, we're only saying that x is equal to 2. Okay, and then we have a line at x equal to 3 parallel to at y equal to 3 parallel to the x-axis. We have a line at this point parallel to the x-axis. Alright, so this line is at the point y is equal to 3 2. Okay, so from this we can say that the given equations for x and y and the equation of a line parallel to the y-axis, which is at 2 units, is given as x equal to 2, as we have here. Okay, and the equation of a line parallel to the x-axis and 3 units, okay, is given as y equal to 3. Alright, as you can see. And so having this knowledge, we can go ahead and define distance between 2 points. Distance between 2 points. Between 2 points. Alright, assuming we have this diagram as our, suppose we have a line AB. Okay, suppose we have a line AB and we wish to determine the distance between the points on the line AB. We should determine the distance between the parallel line opposite to y and the line perpendicular to y and the line perpendicular to x. Okay, we wish to find the distance. Maybe we denote their intersection as n. Alright, meanwhile d is the distance. Okay, so we need to know that the distance between point A and N is x2 minus x1. Okay, that means points on the parallel x line, x1 and x2. Okay, and meanwhile this side the distance between this side points on y. Okay, points on y2 and then y1. Okay, is equal to y2 minus y1. Alright, and the coordinates here is called the x2 and the y2 coordinate, because these are where the two coordinates meet. And then the coordinate at A is the x1 and the y1 coordinate. Okay, because these are the 2 points where x1 and y1 intersect. Alright, we will define the distance between 2 points using our Pythagoras theorem. By Pythagoras theorem, the distance AB squared, okay, for a right angle triangle just like ABN. Alright, let me state that for a right angle triangle ABN, okay, in the figure above we have that AB squared is equal to AN squared plus BN squared. Alright, so where AB squared is a distance of the separation and AN squared is given as x2 minus x1. Alright, and BN squared is given as y2 minus y1, so that D itself will be the square root of their distances of separation, of the sums of their distance of separation, y2 minus y1. Alright, and so this will help us to compute the distance between 2 points. Okay, distance between 2 points will be given as the square root of x2, the difference between the points x2 and x1, and plus y2 and y1. We'll quickly take an example. For example 1. Okay, and you're told to find the distance between the points. Find the distance between the points. Distance between the points. We have coordinates 1, 2, and 4, 6. Always note that whenever you're given coordinates, you're saying x, y. Okay, we are the first bracket denotes x1, y1, and then x2, then y2. Alright, solution for 1. Alright, distance D is given as the square root of the points, difference of points, the sum of difference of points, y2, y1. Okay, alright, so D is equal to square root, and x2 there, sorry, x2, x1, yep, x2 there is 4 minus 1 plus y2 there is 6 minus 2. Alright, so that D will be equal to the square root of 4 minus 1 is 3 plus 6 minus 2 is 4. Okay, so that D will be equal to square root of 7. Right, yep, so the square root of 7 will give the distance of the separation. Okay, that's wrong, we omitted something, squared. I hope it's still on the equation. Alright, please make the corrections so you don't make mistakes again. I didn't see that. Alright, so this is 3 squared plus 4 squared, okay, which is equal to 3 squared is 9, and 4 squared is 16. Fine, and then this gives us 25. Square root of 25, D is equal to 5. So therefore the distance of separation D is equal to 5. Alright, 5 units. Okay, I think we need to take some other example. Example 2. If you're given the coordinates minus 4, and 1 for you to find the distance of separation, and 2 and 9. Okay, you have to find the distance of separation. D is equal to square root of x2 minus x1 all squared plus y2 minus y1 all squared. Okay, D is equal to x2, there is 2 minus 4 all squared plus y1, there is y2 9 minus 1 all squared on the square root. Alright, so therefore we have D to be equal to 2 plus 4 squared, minus changes to plus, and then we have 9 minus 1, we'll have 8 squared. Fine, all in the square root symbol. And so D is equal to 2 plus 4 is 10 squared. Alright, and 10 squared is 100. Sorry, 2 plus 4 is 6 squared, and 6 squared is 36. 8 squared is 64. 36 plus 64 gives us 100, which is equal to 10. Therefore D is equal to 10. So this is the distance of separation. Alright, we'll go over, and the next thing we'll talk about is the midpoint of a line segment. Midpoint of a line segment. Okay, midpoint of a line segment. And so just like we did for the first time, we use diagrams here to make explanations. Suppose we have here with the y coordinate, and then the x coordinate, we have the y negative coordinates and then the x negative coordinates. Alright, and suppose we have a line. We wish to determine the midpoint of this line. Okay, we wish to determine the midpoint of this line, and just like previously, we call this line the line AB, and then here we have our origin 0. Okay, you know, at B point, the coordinates here are x2 and the y2. At A coordinates, we have x1 and the y1. Okay, and so if we want to find the midpoint of this line, okay, maybe we draw a vertical line here. Okay, so we can equally divide the vertical into 2, and then a horizontal line that we will want to divide into 2 too. Okay, we wish to divide these two lines into 2, and we shall call the midpoint of B. Okay, we shall denote here as C, and then call the midpoint of B to be M of x2. Okay, you know, this line is a line of x to y. Okay, and so the midpoint here, you know, you can divide into 2, which is half of the line BC. Okay, and then maybe we make it the 2 points meet at the point where we have half of AC2. Okay, if this is the midpoint of AC, we shall call n of the horizontal axis x1 and y1. Okay, alright, and this point C is made up of the x1 point, of the y1 point, of the y-axis, and then the x2 point. So we can call this coordinate axis x2 y1. Alright, I hope we've denoted all the points. And then this midpoint here, okay, because the vertical and horizontal line gives us the midpoint of the line AB, which we shall call x1 y. All right, the most important thing here is just that we should note that from this division, all we just did was to find the midpoint of the sides such that x1 plus x2 is divided by 2, okay, to form x, and then to form y we have that y1 plus y2, the midpoint at y, okay, over 2. So this is the midpoint of at x, and then this is the midpoint at y2. And so since px is the midpoint of AB, we have that for x you have that an, okay, is equal to nc. All right, for the x axis, or the for the x coordinates rather, for the x coordinate we have that an is equal to nc. Okay, all we are saying here is that that an is the same thing as x minus x1, okay, because at the point where we have this is the whole of this line is the x, and then to obtain an we have to subtract x1, assuming here is x1, and then from x. All right, and then it must be equal to nc, which is equal to x2 minus x. All right, and then carrying out these computations, you can cross over x to the other side, and here becomes x plus x, okay, and then taking this other point to the other side will give us that here becomes x2 plus x1, right, and then we'll have 2x is equal to x2 plus x1, so that x itself will be equal to x2 plus x1 all over 2. Okay, and so we do similar manipulations for the line of y, okay, where we have that cm is equal to mb. Look at the line of y where we have that cm, okay, cm is equal to mb, okay, which are the midpoints, because the lines have been divided into 2, so the midpoints have to be equal. And so we have that y minus y1, which is cm, look at the diagram again, and then is equal to y2 minus y, okay, and then we'll carry out the same computation, and so we have 2y is equal to y2 plus y1, okay, so that y will be equal to y2 plus y1 all over 2. And so the coordinates of points p and x will have the midpoint. The coordinate of points p of x and y are the midpoints of AB, okay, will be equal to x1 plus x2 all over 2, and y1 plus y2 all over 2. All right, so we take example. For example, okay, example 1, you are given this triangle, all right, and the coordinates are the points A, M, and B, and C. At the point C, you have the coordinate 1, 2, and then at the point B, you have coordinates 8 and 7, and then at the midpoint, we have PQ. We don't know this, and then at A again, we have 8 and 5. Okay, these are the points on the coordinates, and you're told to calculate. Number 1, the coordinates of the point M. Calculate the coordinates of the point M. Okay, and if you look at the diagram very well, you find out that M is the midpoint and the distance or length of CM. Okay, find the distance or length of CM. And number 3, we have to show that the triangle, ABC is a scaling triangle. Alright, so how do we go about this? All we need to do is to first find the midpoint of the triangle M. Solution, we use the formula we've obtained for midpoint equal to x2 plus x1 all over 2, and then y2 plus y1 all over 2. Okay, and so for the coordinates M, P and Q, okay, we'll have that M coordinate will be equal to, we have x2 and x1 being the points on the opposite coordinates, and then we'll have 8 plus 8 all over 2 for the x. Okay, and then we'll have 7 plus 5 all over 2 for y. All we just did was to pick the x as the coordinate for the x is 8 and 8, and then the coordinate for the y's, okay, 5 and 7. Alright, to get M coordinates to be equal to 16 over 2 and 12 over 2. Okay, so M coordinates will be equal to 8 and 6. And so we go ahead to find the distance CM. Number 2 says we should find the distance of CM. Alright, and I hope we've not forgotten the formula for distance defined as x2 minus x1 and then y2 minus y1, the sum of their distance of separation, x2 minus x1 and then y2 minus y1. Okay, so we have this distance as x2 minus x1 squared plus y2 minus y1 squared. Alright, so the sum of distance of separation CM, look at the two coordinates there. We have C for x coordinate, for x we have 1, for x for y2 we have 2, and so we have distance CM to be equal to square root of we have x2, right? We have the coordinate M to be equal to 8 and 6, and then coordinate C to be equal to 1 and 2. Okay, so we have 8 minus 1 all squared plus 6 minus 2 all squared. Okay, and so we have the square root of 8 minus 1, which is 7 squared. Alright, 6 minus 2, which is 4 squared. Okay, this gives us the square root of 49 plus 16, and then we have the square root of 65. Root 65. It's not a perfect root, so we leave it in that form. So distance CM is equal to 65 units. Alright, so we go ahead and prove whether they are a scaling triangle, and the only way we can do that is to prove what the distance between the other sides are. All right, and then for distance AC, we have using the formula at CM2, AC have coordinates 8 and 5, and C have coordinate 10, 1 and 2. Okay, this is for A. And so we have x1 minus x2 as 8 minus 1 squared plus 5 minus 2 squared, rather 2, yeah, 5 minus 2 squared. Is that right? Okay. And so we have this as the square root of 7 squared plus 3 squared, okay, which is equal to square root of 49 plus 9, okay. And then we have this as the root of 58 units. All right, with this alone, okay, we need the other side to prove that even if it's the two sides differs, maybe the other side could be equal to one of the sides, and then it would be an isosceles. But let's find the distance of BC to prove wholesomely that it's a scaling triangle. Distance BC, okay, BC have coordinates at C as at B we have 8 and 7, and then at C we have the coordinates 1 and 2, okay. And using the same formula, we have square root of 8 minus 1 all squared plus 7 minus 2 all squared. Right, and so we have distance BC to be equal to 7 squared plus 5 squared all squared, and so we have 49 plus 25. Okay, and when we sum together, we have square root of 74 units. Okay, you can see that they have different units on their sides, and so therefore, since they have different units, okay, it then goes to prove that it's a scaling triangle. Okay, so which means their sides will not be equal because their units are different. All right, the next thing we'll talk about is point of division on a line segment. Points of division on a line segment. Okay, points of division on a line segment. All right, we shall illustrate using our coordinates again. The coordinates, I'm going to draw them. So here we'll be dividing a line joining two segments, joining 2 points into segments rather, and we divide them not in equal proportion but in a defined ratio. Okay, for instance, just like we have in a coordinate P of x and y, okay, where we still have a points AB. Alright, we wish to divide the line of x, okay, the line parallel to x, into a defined proportion, say P and Q, into a defined proportion, say P and Q. So we're saying we want to divide this line into a defined proportion, say P and the Q, so that here becomes P and here becomes Q. Alright, and I wish you've not forgotten that the coordinates of points here are x2, y2. The coordinates of points here are x2, y1. Okay, and then the coordinate of points at A, x1, y1. Alright, okay, so if we divide this line into proportions, say at this point n, okay, And so we want to find out the ratio of proportion for which the line has been divided. Okay, and so we have to note that from the plane of figures above, from the plane geometry, okay, of figures as depicted in the diagram above, okay, you have to note that AP, for the line AP, okay, not equal. We're only saying that, I'm just looking for a way to put this. I'm only trying to say that, look at the point P here, okay, the line of P. You find out that P divides the line of AB such that AP is proportional to PB. Okay, AP is proportional to PB. Okay, and which we could say they share a defined ratio of P is to Q. Okay, just like we've said here. Okay, and you know that in ratio we can as well represent ratios in fraction. Okay, and then we have that we can write AP is to PB to be equal to AP over PB. Okay, we can write ratios in fraction, and then for the line parallel to the y-axis, okay, the same thing applies. Okay, the same thing applies, and then we'll have that AB over PB, okay, as the proportion of this ratio on the line parallel to y. Alright, so we want to go ahead and prove that for the proportion PQ, that x is equal to Q of x1 plus P of x2 all over P plus Q. Okay, for the line of x. Okay, we want to prove this. Alright, so we'll consider the line of x, and so we'll say that for them to have similar figure, that AP, okay, the proportion of AP over PB must be equal to the proportion of points for which the line ANC is divided. Okay, we're only saying that AP over PB must share a direct relationship with AN over NC. Okay, that is to say that P over Q, because AP is equal to P from this point AP, distance AP will have P here, distance PB will have Q here. Okay, alright, P and PB is equal to Q. Alright, and then AN is x minus x1, we've said this previously, while Q is x2 minus x. Alright, and so therefore we will cross multiply. We had PQ is equal to x minus x1, and then x2 minus x. Okay, and so we have P of x2 minus x is equal to Q of x minus x1. Alright, and so we multiply into the brackets, then we'll have P x2 minus px is equal to qx minus qx1. Alright, so we take the identical signs together, and so we have the signs with the subscript coming together. Alright, and the sign without subscripts grouped together. Alright, and so from here we have that P of x2 plus Q of x1 is equal to x of Q plus P. Making x a subject of formula, from this point we have that x is equal to P of x2 plus Q of x1, okay, divided by Q plus P. Alright, and so this gives us the ratio of internal division. Okay, if we carry out similar workings for the y-axis. We will still have q of y1 plus q of plus rather p of y2 all over p plus q. Okay, all right. So we will have to apply this to using this example. Example 1. Find the coordinates. Find the coordinates of the point. Find the coordinate of the point P of x and y, which divides the line segment from the point A of 2 and 3, and then B of 6 and 11 in the ratios of 2:3. Alright, all we have to do is to extract our formulas, and then we have x for the point x solution. Alright, for the point x we derived that q1x plus p of x2, okay, all over p plus q. Alright, so we have these coordinates 2, 3, 6 and 11, and then this is our x1, y1, x2, y2, and then 2:3 pq. Alright, pq. And so we go ahead to 3. Okay, so that means x will be equal to q is equal to 3, x1 is equal to 2, and then p is equal to 2, x2 is equal to 6. Alright, and then p plus q is 2 plus 3, okay, which gives us 3 times 2 is 6, 2 times 6 is 12, and then this gives 5, 18 over 5. Alright, and that gives us 18 divided by 5 gives 3 whole number, 3 over 5. Alright, so this is the coordinates of the point xy, which divides the line segment into the ratio 2:3. And then for y we derived that we want to find the coordinates of the point for y, and then we have y q of 1 plus p y2 all over p plus q. Okay, and so we go back to our equation. Here we have that y1 is 3, y2 is 11, y1 3, y2 11, and pq is 2 and 3, 2:3 pq. Alright, so we have q to be equal to 3, y1 equal to 11, and then p equal to 2, y1 equal to 3 rather, okay, y2 equal to 11, and then p plus q equal to 5, and so we have 9 plus 22 all over 5, and this gives us 31 over 5, and further division gives 6 on number 1 over 5. And so this is the coordinate of the points for the point P, x and y, alright, that divides the line segment of the two lines A and B in the ratio 2:3. 2:3. Alright, so at this point in time, we talk about external division, because the one we just did is the internal division, the point of division on the line, okay, or what we also call it the internal division. Alright, and so we'll quickly go and talk about the external division. Alright, we'll still use our formulas for the internal division, and then we'll have the external division. We only make some rules that will help us carry out external divisions. Alright, I want to state that the external division for the x-axis, external division for x, okay, coordinates, sorry, for the x coordinates, okay, or the x abscissa, is given that the ratios are represented as follows. The ratios are given as p is to minus q, and then the external division on the y coordinates, okay, the ratios are given as minus p is to q. Alright, so when you are given two ratios and you have to do external division, it means that you have to switch into for the x-axis, the ratio q will be negative, and for the y-axis, the ratio p will be negative. Okay, let's try doing that with the first example we did, where we had 3 from point A. Let me see. Alright, I think let's pick another example. I would have loved to use previous examples, but let's pick another example. Example 1. A and B are points. A and B are points 11 and 2 and 2 and 7, okay, respectively. Alright, I have to find the coordinates of points. Find the coordinates of points of the point which divides AB internally and externally in the ratio 2:1. Alright, so we have coordinates of points 11 to 7. A solution, okay, the points you have are 11 2 for A, and then for B we have 2 7, and then for the ratio we have 2:1. Alright, we start with internal division. Internal division on x is given as qx of 1 plus p x2 all over p plus q. Okay, this gives us q here is 1 times 11 plus 2 times x2 is 2 all over 3. Okay, 11 plus 4 over 3, which gives us 15 over 3, and here we have 5. Okay, so x is equal to 5, and then the internal division of y is given as q of y1 plus p of y2 all over p plus q, which is equal to, we have q as 1 times y1 is 2 plus 2 times y2 is 7, right, over 3, and so you have 2 plus 14, okay, to give you 15 over 3, 16 over 3 rather. And so we have that y will be equal to 5 for number 1 over 3. All right, so this is for the internal division of the external division. Okay, for the external division, the ratios changes. For x, external division of x, the ratios changes to we have p and minus q, so here becomes 2 and minus 1. all right, and so x becomes q of x1, all right, minus q of x1 plus p of x2 all over p plus q, okay, which gives us minus q, sorry, we shall use as 1. okay, whenever you use minus q, do not put negative sign here, but if you are using q minus q here will be positive, okay, it will remain the way it is. But if you are not using minus q, if you are using q, okay, you can leave this, change this to positive, so you don't confuse yourself. So q here is minus 1, and then x is x1 is 11, okay, and then p is 2 and x2 is 2 all over 3, okay, and sorry, this changes to minus q, and 3 times q minus 1. all right, and so we have this to be equal to minus 11 plus 4 all over 3 minus 1 is 2. all right, minus 11 plus 4 will give us minus 11 plus 4 gives minus 7, and so x is equal to minus 7 over 2, which is equal to minus 3 whole number 1 over 2. all right, so this is the internal for x. This is the internal for x, and to obtain the internal for y, we do as follows. For y, we will have y to be equal to, then the ratio changes to minus 2 and 1, right? Yes, the ratio changes to minus 2 and 1, and so we have for y, we said the ratio for y, p becomes minus 2 and this becomes 1, so the ratio changes to minus 2 and plus 1. I just wish you will understand. And so we'll have minus 1 times 1 plus 2 times 7 all over 2 minus plus minus 1, all right, and then which is equal to minus 1 plus 14 all over 1, okay, so which is equal to minus 13, sorry, which is equal to 13. And so therefore p for these points will be minus 3 over 2 and 13. all right, for the external points. And so with this, we've come to the end of our class on coordinate geometry. Catch you up in the next class. Bye.